Hey guys, today we are going to start talking about sine and cosine graphs, which is hopefully going to be a little bit of review for y'all, but if it's not, then that's okay because we're going to kind of just start here from the beginning. So the first thing I did, and normally this is something that we would do like together in class, but that's not really possible right now. So I filled in this table that has a bunch of different values of the sine of x. And if you look at all of these values, they are different places that are found on the unit circle. And so then I graphed my x's and my y's, and I made just a basic graph of the sine of x. And then I went through each of these, and these are the things that we're mainly going to be talking about today is like the period of a graph, the amplitude, midline, and stuff like that. The max and min a little bit, but it's not going to be as important. But that's kind of like just where we're going with this. But first, I just wanted to show you, here's the graph of sine of x. And then here's cosine of x. So I did the same thing. These are values from the unit circle, and it's going to look really similar. And then also keep in mind for both of these that they're going to be cyclic equations. So after I get through one little, it's going to be called a period. Once I get through one period of this, it's just going to continue to repeat itself. So it's going to have this look to it, where it just keeps going up and down over and over. So one of the first things that I want to do is look at some similarities and differences between the sine and cosine graphs. So some of the stuff that's the same, if you look at the 5 things I have listed down here, I have the period is 2 pi, amplitude 1, midline at y equals 0, and the max is 1 and min is -1. If I go to cosine, I have the period is 2 pi, the amplitude is 1, the midline is at y equals 0, the max is 1, and the min is -1. So that's all the same information that I had for sine. So for the basic sine and cosine graphs, the things that are going to be the same are the period, the amplitude, and again, we're going to talk about what these are, the max and min, and the midline. So the main thing that I want you to notice that is different though is for sine of x, where we started on the graph, it was at the origin or at y equals 0. And at that point, that's where we're on the midline. For our cosine graph, we started at 1, which is going to be our maximum. So for differences, what I want you to make a note of is that the sine of x is going to start at the midline, and then the graph for cosine of x is going to start at the maximum on that graph. And so that's just something that's going to be helpful whenever you're trying to look at a graph and write an equation from that graph, is to know these 2 things. Okay, so then we're going to start talking about like what some different pieces in these equations are. So I put our little basic equations up here for sine and cosine, and we have an A, a B, a C, and a D in here, and those are all going to shift the graph in different ways. So the first one we're looking at is what's going to shift the graph up and down. And so just like in a lot of other equations, the thing that's going to shift the graph up and down is going to be the number that is added or subtracted on the end. And so that's going to be D in this scenario. And so what D is actually going to be and what it's going to represent is going to be the midline of that graph. And the midline is always going to represent the average value of the graph, because no matter how many times you go up and down, it's always going to average out right there in that middle area. So the midline is going to represent an average. And then to find the midline, one method you could do if it wasn't necessarily given to you is you can add the maximum and the minimum, and divide by 2. And in that scenario, again, you're just finding the average of the maximum and minimum. So remember that the midline is going to represent an average. So like if you're given an equation and you're given a word problem or something like that, and it has an equation there for you already, and it says like, what's the average temperature or what's the average water level or whatever at like on a certain graph, then the average is always just going to be whatever that midline is. So the next thing we need to look at is what's going to shift the graph to the left and the right. So just like with a lot of other equations, that's going to be whatever the number is that's being added or subtracted in there with the x. So that's going to be c. And then what that is going to be called in terms of sine and cosine is it's called the phase shift. And that is just kind of like because it's shifting where the graph starts. So that is what I'm going to refer to whenever I'm talking about the graphs of these shifting left and right. The next thing that we're looking at is going to be causing a vertical shrink or stretch. So we've looked at this in the past with other types of equations, and what is causing vertical shrinks and stretches is whatever number is just in the very front being multiplied by our sine or our cosine. And so that is going to be A. But then we aren't going to worry about if A is negative necessarily because that's just going to flip it over the x-axis. So instead of just saying A, I'm going to say the absolute value of A. And then what that vertical stretch or shrink is going to be called is going to be the amplitude. And then the amplitude is going to be the distance from the maximum or minimum on a graph to the midline. And then, like I said a minute ago, when it's negative, that's just going to flip it over the x-axis. So that's why we don't have to worry about that whenever we're talking about the vertical shrink or stretch, because we're not going to say a graph has a vertical stretch of -2 or anything like that. So that is going to be all for amplitude. And then our very last thing is going to be representing a horizontal shrink or stretch. So this one should probably be a little bit new, and that's going to be affected by that B value. So our B value is going to represent a horizontal shrink or stretch. And then the B value is also going to help you find the period of the graph. So don't get confused and think that B is the period because it's not, it just helps you find it. So to find the period, B is going to be 2 pi divided by the period. Or if you don't know the period, then the period is going to be 2 pi divided by B. So that is going to be something that you're going to want to remember to be able to find the period using that B value. So then I just want to go through and label some of these different things on the graph. So one thing that sticks out that should be pretty easy to label is going to be the midline. So that's just the line that is the average between the max and the min. And then the next thing is going to be that distance between the midline and a maximum or minimum. And that is going to be called the amplitude. And then the last thing that I have labeled on here that you need to be able to find is going to be the period. And so the period is going to be the distance between two maximums or between two minimums or just like a section of the graph before it starts to repeat itself, essentially. So I'm going to label both of these. Then I also want to write out that it's going to be the distance between two maximums or two minimums. Because that's going to be one easy way to find the period whenever you're just looking at a graph. So you're going to want to write that down. And then the bottom one down here, where it's showing it, let me just highlight that portion of the graph for you. So it goes from the midline up to the maximum, back through the midline down to the minimum, and then back to the midline again. And then if I started on this part, and I kept going, it's just gonna repeat itself basically. So if you get to a point on the graph, say like right here, and it starts to repeat what you already have, then you know that the period has ended and you're starting something new. So that's another way to look at it if that helps as well. So then I'm just going to do a couple of quick examples where we identify the midline, amplitude, period, and phase shift. So I'm going to write out what all it's asking for. Midline, amplitude, period, phase shift. And I want to find each of these things on the graph or with the equation. We're not actually going to look at the graph to do it yet. So for the midline, remember that it's going to be whatever the d value is, and that's -4 in this one. So we're going to have y equals -4. For the amplitude, it's that a value, whatever is in front of or being multiplied by your sine or cosine. So in this case, that's 2. The period is 2 pi over the b value, and in this one, the b value is 3. So that one's just going to be 2 pi over 3. And then for the phase shift, we have plus pi. So if you guys remember from previous types of equations or previous math classes or whatever, anytime that you have something added or subtracted like inside those parentheses, it normally moves in the opposite direction from whatever the sign is. So the plus pi is actually going to move us to the left by pi units. So then why don't you guys try to do number 2, and then you can unpause whenever you're ready to see that gone over. So we have midline, amplitude, period, and phase shift. So first with the midline, it's the number that's added onto the end, and this one it's 1, so it's just going to be y equals 1. For the amplitude, it's that number in the beginning, so this one's going to be 3. For the period, this one can be a little bit tricky. It's 2 pi divided by b, and b in this case is 1/2. So if you do 2 pi divided by 1/2, then you're going to end up getting 4 pi, and that's because you would have like 2 pi over 1 divided by 1 over 2. But then since you're dividing a fraction, you would end up having like 2 pi over 1 times 2 over 1. And then whenever you multiply all of that out, you end up with 4 pi over 1. And so the period is just going to be 4 pi. And then for the phase shift, we don't have anything being added or subtracted in there with the x, so there's not going to be one in this equation. So the last thing I want to do is just to try to write some equations given the information. And so for our first one, and I'm going to go ahead and write out the equation with blanks in it first. So I'm going to have y equals a times, and it's telling you it's a sine equation that it wants you to write. It could be a cosine equation, but it's telling you to write a sine equation. So a times the sine of a blank. And then times x, and I'm going to write plus, it could be minus, but plus or minus c, and then plus or minus d. So now let's go through and just start filling in the blanks. So it tells us very beginning amplitude is 6. So that means that our a value in front needs to be 6. And then it says the period is 12 pi. So be careful there again, because we need to use the fact that b equals 2 pi divided by the period instead of just throwing that 12 pi in there. And so then when you simplify that down, the pi's are going to cancel, and you'd have 2 over 12, which simplifies to 1 over 6. So the b value that goes in that blank is going to be 1/6. A phase shift to the right by 2 pi. So then since it's going to the right, that actually is going to be a minus sign in there. So it's going to be minus 2 pi. And then the midline is y equals -3. So that means I need a minus 3 on the end. So that would be how you write that first equation. And then I'm going to let you guys try the last one. And then just like before, unpause whenever you're ready to see it all written out. So we're going to have y equals, and then we need a first, which is the amplitude, which is 2, times the sine of whatever our b value is. So b is going to equal 2 pi divided by the period, which is pi over 4. So I'm going to scroll down here so that I can actually work that out. So I would have 2 pi over 1, and then divided by pi over 4. And then I'm going to rewrite that as 2 pi over 1 times 4 over pi. And that is going to become 2 pi times 4 is 8 pi over 1 times pi is pi. And our pi's cancel, so it would just be 8. So our b value for this one is just going to be 8. And then we have x. The phase shift is to the left pi over 6, so that's going to be a plus pi over 6. And then the midline is y equals 5, so that's going to be a plus 5 on the end as well. So that's going to be it for today on the sine and cosine graphs. And then for tomorrow, we're going to be working on how to write the equations if we're actually looking at a graph of it and we're not given the equation. So we're going to have to be able to identify each of these things, the amplitude, midline, period, and stuff like that on a graph as well, starting tomorrow.